Some time ago, Toralf Klatt asked me if I would like to hold a presentation at Business Agility Meetup Berlin. I said yes and held a presentation on the 17th of May in 2022. And this is that presentation. Welcome to Lost Treasures of Agile. My name is Henrik Mårtensson and I've been working with Agile software development methods since 2001 as a developer, Scrum Master, coach, process expert and troubleshooter. I'll be talking about great ideas in the Agile community that have fallen by the wayside over the years. Now, in the beginning, before the Agile Manifesto, we had several methods that would later become known as Agile methods. In 2001, no single method was dominant. It was pretty much an open field, and if you were interested in Agile, it was natural to learn from all of them. Now I'll talk about just 3 of them. The others have great ideas and practices too, but it would simply take too long to go into them. Actually, I'll just give you a few samples of the 3 methods I will talk about. I hope it will be enough to whet your appetite so you will want to discover more on your own. The one latecomer to the field here is lean software development. The people who created it, Tom and Mary Poppendiek, were not at the original Snowbird ski resort conference where the manifesto was written. They got involved right afterwards, though, and their first book on LSD came out in 2003. I'll also talk about something more related to the business side of Agile. Uda, the Uda Loop. Now, let's get going. We will start with extreme programming, created by Kent Beck in the 90s when he was managing a project at Daimler Chrysler. If you know about extreme programming, you have probably heard of practices like pair programming and test-driven development, but that's actually not what I'm going to talk about. Instead, we'll look at some fundamental ideas behind extreme programming. Everything in extreme programming is geared towards reducing risk and uncertainty. The idea was that increasing complexity drives risk, and risk is what drives the cost of change up, not only during a project, but over the whole life cycle of a project. Beck figured out that if you could reduce complexity, you could reduce cost, while at the same time making life much more pleasant for developers. And this led to Beck's second big idea: to create a system of supporting practices. Beck borrowed ideas from systems thinking, a holistic approach to problem solving, focusing more on the relationships between the parts rather than the parts themselves. Now compare with what SAFe did with its Scrum XP implementation. Most practices were removed and you now have a much weaker supporting framework. If you read the SAFe documentation, it's clear that these practices are seen as useful but independent software engineering practices, not as a self-reinforcing system of behaviors. Now in practice, I've never seen a SAFe team use anything other than continuous integration. Even if an individual programmer wants to work test-driven, the rest of the team does not, so in practice they end up coding first and writing tests after. Pair programming is almost as rare. Developers either sit alone at their desks or work from home. Now Scrum is worse with no development practices at all. Here's a different way of looking at the same thing. All XP practices create feedback loops with information flowing to the developers. Pair programming provides the fastest feedback loop because 2 developers sit and work together. With test-driven development, the feedback loop is a couple of minutes. When we remove practices, we remove feedback loops, and without the fast feedback loops, we can't be very agile. Extreme programming introduced another systems thinking concept, self-organization. This was later picked up by Scrum and other methods. Unfortunately, that happened without anyone bothering to look in a systems thinking textbook, and figuring out what self-organizing really means. Now, this is a picture of system intervention points, that is pressure points you can use to change a system and their relative strength. Some things here might surprise you. For example, the weakest intervention point, constants, parameters, and numbers, well, that translates to things like OKRs, objectives and key results in the business world. Self-organization includes control of all the intervention points below it on the scale. Now, self-organization, if adhered to, gives teams powers you might not expect. For example, control of the structure of information flows means a self-organization team has the right to fire the product owner and talk directly to the customer. It's just as important to look at what self-organization doesn't allow a team to do, because this is the realm of managers. Managers set system goals, such as the goals of a project or program. They work with paradigms, such as Theory Y, the mindset underlying all early Agile methods, and systems thinking, complexity thinking, variation, psychology, epistemology, and neuroscience, different economic models, and they work on how to integrate them and shift between them to shift viewpoints. What they should not do is mess around with low-power intervention points, and worse, outright management superstition like OKRs and Myers-Briggs personality tests. Now, sadly, I've seen management in pseudo-agile organizations do exactly this. From big ideas to small, extreme programming also had ideas about how to sit and work together. An enclosed space for the team with a central area where people could work together in pairs. At the edges, peripheral workspaces where programmers and pairs can work in a bit more isolation if they need to. This is actually the inverse of a famous architectural design pattern called Caves and Commons. The XP version focuses on close collaboration and teamwork. Open office seating schemes were not recommended. I want you to remember that, because we'll return to it when we talk about lean software development. Here's a picture of two XP developers sitting at a custom-made pair programming desk. Note the curved edge, allowing a pair of developers to sit turned slightly towards each other and easily talk and look at the same screen. Now, self-organization gives developers control of their work environment. So at some companies, the developers design their own pair programming desks. This picture is from Tempo, a book on modern management that I published in 2010. An updated and rewritten version in English is in the planning stage, but don't hold your breath. I've got at least one other book to write first. Now, one important idea that I do not see much of in practice is the idea of emergent design. The idea is that instead of doing a lot of upfront architectural planning and sticking to your plan, you refactor mercilessly while you work. This allows the architecture to emerge and evolve as your understanding of the requirements improve. Of course, for this to work, you need to be able to do refactoring without code breaking, and that means you need test-driven or behavior-driven development. You need to discuss architecture decisions on the fly, so you need pair programming. You may need to change code you haven't worked on, so collective code ownership and common coding guidelines help a lot. When we threw out technical practices like test-driven design and simple design, along with supporting practices like pair programming, we made emergent design very difficult. That pushes us backwards towards more design up front and thus less ability to change. Now, you can do Scrum, Safe, and DevOps all you want, but if the code base can't be easily changed, you can neither respond to change nor initiate change, and then you're not very agile. Let's have a look at Crystal Clear, created by Alistair Coburn. Crystal is really a family of methods. Clear is the one adapted for single team development. There is plenty of gold to mine here, so Like before, I'll scratch the surface, show you where it's gleaming, and let you do the serious digging of the gold on your own. Now today we emphasize flow over value. We talk a lot about improving flow, but really very little about improving the value of what we deliver. Now Crystal Clear had a better balance because Crystal had something that made it easier to do the right thing. It's something that disappeared from Agile for several years, but is now making a little bit of a comeback. It's UX design, of course. Now SAFe puts at least some emphasis on UX design. I have even worked in a Scrum team with a UX designer. Now the difference seems to be that 15 years ago, as a UX designer, you had to study, learn, and know a lot. The UX designers I meet now are usually design thinkers with much less design knowledge and a tendency to misunderstand how to write user stories. Perhaps it's just me getting old and grumpy, but then again, perhaps it's not. Now, a key idea in Crystal Clear is that when you build a system, you start with the smallest thing you can do that works end to end. Now, this can be as small as sending a hello world message from the user interface to the backend database, or if you have a distributed system through all of them that you want to link up. Once you get this walking skeleton working, you expand it and add new things that it can do. And yes, you refactor mercilessly to make it possible to evolve the design so that it supports what you want to do as smoothly as possible. In Crystal, building on the skeleton in this way is called incremental re-architecture. It's the same idea as emergent design in extreme programming. What I like about Crystal is that the walking skeleton idea is more clearly defined. Crystal has plenty of useful ideas, but we'll skip straight to our next method, which is lean software development. In 2003, 2 years after the Agile Manifesto, Mary and Tom Poppenjake published Lean Software Development, a book chock full of great ideas and practices, including maybe the first Kanban system for software development. Lean software development had plenty of other good ideas though. One of those ideas was translating the 7 wastes of lean to corresponding wastes in software development. Now, why is this useful? Because it gives you hints about what to look for when you are debugging or optimizing a development process. Another very useful tool is value stream maps. You map out how work items like user stories move through the process, how long they are worked on in each step, and how long it lies in wait between the steps. That makes it easier to figure out how to reduce or eliminate wait times in the development process. Another cool idea is set-based development. If I Google the terms set-based and agile, I get less than 600,000 results. That's not much, considering that understanding set-based development is the key to understanding something very important about Agile, namely how iterations are supposed to work. Let's start by looking at something you are almost certainly familiar with, an ordinary design cycle. Developers design, which means they plan how to write code and then write the code. Then the code is reviewed. That's what happens during a code review or a Scrum or SAFe demo. Based on the review, the developer modifies the code and then the cycle starts again. This is called point-based development. However, there is another way. It's called set-based development. The idea is that during early iterations, you create as many options as you can. Then you begin to merge them until you converge on a single solution. Here is an example. Imagine you have several teams building a distributed system. The parts need to talk to each other. That means they need a common language so they can understand each other. We call this an exchange format. Now, our task here is not describing the exchange format. We'll just decide how to describe the exchange format. Now, if you work the point-based solution way, you'll just pick what you're comfortable with. Some time ago, I worked with an organization that did all of their information modeling using UML to create an object model and Excel to list the attributes for every object, to add information like the data type and a description of the attribute. The teams worked independently of each other, but they all used the same information model to develop interfaces for talking to the other applications. Now this seems reasonable, right? Except for one thing. After 4 years of work, the parts could not talk to each other, even though they all followed the same specification. Why? Let's use set-based development and see if that can tell us why they got into trouble and how to come up with a better solution. First, let's develop a set of options so we have different alternatives to work with. The UML plus Excel option is language independent. All the others are tied to specific data formats, JSON, YAML, and XML. RelaxNG is a language for describing XML. It's different from XML schema, but basically does the same thing, in a very different way, though. Instead of designing, reviewing, and modifying as we would with point-based development, we develop a set of constraints. We base this on things we know we want to be able to do. For example, it would be neat if we could have the applications validate messages directly against the description of the exchange data format. Now that way, an application can easily check that it uses the correct format for a message before it sends it. A receiving application can check incoming messages to see if they are valid before doing anything else with them. Perhaps best of all, it reduces uncertainty when developing the applications, so teams spend a lot less time misunderstanding each other, which means they have to do a lot less rework. As it turns out, with UML we can't do that. We can draw a pretty diagram, but it's just a picture, not a schema good for validation of messages. That means UML plus Excel is the first option we scratch off our list. We still have documentation in an Excel file. What if we could document everything in line, in the schema itself? Then we could keep the schema and its documentation in the same file, which means much less work keeping the documentation up to date. Not to mention, we always have it available when we work on the schema. JSON doesn't do that, but its big brother YAML does. So do both XML schema and RelaxNG. We expect the schema to be fairly complicated, and it might be a good idea if we could make customizable modules, because while all the communication will be about similar things, all messages won't necessarily be exactly the same. That didn't really change anything this time around. Our remaining contenders all move on to the next round. There will be complicated many-to-many and maybe bidirectional links between data objects in our schema. This eliminated YAML. YAML supports links, but not the powerful link bases we need. In the project I mentioned before, the decision was to use UML plus Excel to model JSON messages. It turned out that the relationships in the UML model could not be easily implemented in JSON. Because the project locked in on UML and JSON very early in the project, they never considered other solutions, and that cost them dearly. A slow 4-year death march. Yeah, there were other problems that contributed to the demise of the project, but several of those problems could have been solved with set-based development. Let's add one final constraint. Not everyone who develops the schema will have access to fancy schema editors, so it's important that the schema can be easily written and maintained using a simple tool, a text editor. And that killed off XML schema. While it's possible to edit XML schema in a text editor, XML is not designed for that, and it's painful. Now, in our example, the little known RelaxNG is actually our best choice for schema language, given this set of constraints. As a bit of icing on the cake, RelaxNG schemas can be automatically converted to XML schemas, so if we need to, we can easily back out of our decision to use RelaxNG then buy nifty XML schema editors for everyone and continue to work. Going the other way from XML schema to Relax would be a lot harder and more expensive. Here's a thing that might shock you. The above quote is from the Lean Software Development book, and it's actually a correct statement. Thinking of an iteration as a point-based solution is a misinterpretation of iterative development. Iterations are set-based. If you work point-based and just add more and more stories, you work incrementally, not iteratively. The design will evolve, and in that sense, the early iteration is a prototype of a piece of the overall design. If this reminds you of the walking skeleton practice in Crystal Clear and emergent design in XP, you are correct. It's different perspectives on the same thing. Now, wait, there's more. Aggressive refactoring is the key to making sure that iterative development converges on a solution. There is that aggressive refactoring thing again. We are back to test-driven development as a key practice in Agile software development, because without it there will be no aggressive refactoring and thus no iterative development. Now, all the methods we have looked at here so far are set-based iterative methods with aggressive refactoring. On the other hand, Scrum, according to the Scrum Guide, is incremental, not iterative. There is no refactoring. SAFe tries to be set-based. It's actually the third founding principle of SAFe. But then SAFe has made TDD and refactoring optional, and that means SAFe has basically killed off part of its own foundation. One interesting thought, of course, is if set-based development is an indispensable part of iterative development and we don't do it, does Agile even exist anymore? Or is working with point-based increments instead of iterations good enough? Now, personally, I think not. It's okay to work incrementally in the later stage of a project, but if you do that from the start, you will almost certainly end up with a bad solution, and probably a bad, difficult to change solution. Okay, let's not dwell. We'll push on to some happier thoughts. Namely, learning from the Marines. Lean software development is not just a translation of lean practices. It also draws inspiration from several other sources, not the least of which is the US Marine Corps. Lean software development mines and adapts plenty of material from the Marines, but I'll show you just one, and it's pretty important. It's the idea of extreme training. Software development is difficult, now so is management. Therefore, you need to train a lot. The idea is to train as if you were an elite athlete or a Marine. Now, when I became interested in Agile, I spent about 10 to 15 hours a week learning and training. That included reading about 20 work-related books per year, working on personal programming projects, doing code katas with my teammates, learning new programming languages, and so on. Now, I think I was about average for my group. I'm not saying everyone has to be that extreme, but I am saying if you want results, you have to put in the effort. Most problems I see in development organizations could be avoided if managers and developers would actively seek out knowledge and train themselves so they know how to use it. Besides, if you do it right, it's actually quite fun. Lean software development uses queuing theory to teach how to organize the work and optimize processes in a very systematic and effective manner. When Agile methods began to gain traction, there was quite a bit of research on them. It was found that Agile projects delivered 5 to 6 times faster than waterfall projects. I mentioned this in a presentation in Malmö in Sweden in 2008. The whole room cheered, and then I asked, why? Agile developers don't work 5 to 6 times faster. You can't hit the keys on the keyboard 5 to 6 times faster. The room went quiet. We had a room full of Agile practitioners, and nobody could explain what made their way of working work. Fortunately, queuing theory can. The explanation can be found in a famous law of queuing theory, Little's law. The law says that the lead time of a system equals the number of jobs in a system divided by the processing rate. That means we can reduce lead time two very different ways. You can increase the processing rate, which basically means you increase the number of people who work longer hours, skimp on testing, skimp on training, skimp on everything except chugging out code. The other option is working smarter. That's what we do when we set WIP limits for a team. What more can we do to work smarter? Queuing theory informs us work should arrive in small batches. No building up of requirements before development starts. Many Agile projects fail before a line of code is even written because of a big upfront requirements phase. I have worked in a SAFe program that spent a year working on requirements before coding even started. That means lead time increased by a year that is impossible to get back. If we can reduce the size of our work packages, we can reduce batch sizes, which reduces wait times in the process. A queue is at least as long as a work package, so smaller work packages means we can move material in smaller batches. A common mistake is to just chunk work up in small tasks that still have dependencies. That does not work because you don't actually make the work packages smaller, you just disguise them. Now, to do a good job requires good understanding of how to write stories and of the system's architecture and of the dependencies between parts of the system. Now, the next step is to remove variability in processing time. Imagine you have 4 people in a project, an analyst, an architect, a developer, and a tester. What can you do? The easiest way to solve this problem is to increase the number of parallel servers that process work in a single queue. In other words, use T-shaped people or full-stack developers. How do you find these superhuman people? Well, you don't. You grow them. We are back to extreme training. For Agile to work really well, an exceptional amount of training is required. Now that also means you must cultivate your people over long stretches of time, which means you can't rely on resource consultants because they won't stay long enough. Queues have some interesting and often misunderstood properties. Now consider what happens on a highway when traffic increases. Queues start to form long before we have 100% utilization of the highway. A car that moves slower than average will soon have a queue of cars trailing after it, and that delays all of the cars in the queue except the first one. The same things happen with stories and features in a software development project. As we increase capacity utilization, we get more cost effective. That is, the capacity cost goes down because everyone is working all the time. However, the queues cause delays, so the queuing cost goes up. If you reach 100% capacity utilization, you'll also reach a point where queues grow towards infinity and nothing gets finished ever. Now, the loss of this understanding of queues has practical consequences. For example, product owners start to assign work to developers, which means they will cause queues, which means they slow the work down. Another bad practice, managers assign Scrum Masters to more than one team, because the Scrum ceremonies take so little time. This works as long as the Scrum Master doesn't actually do his real job: problem solving, impediment removal, coaching, training. If the Scrum Master tries to do that, queues will quickly form and improvement work in all the teams will slow down. Lean software development incorporates some ideas from the theory of constraints management system. Theory of constraints has an interesting process improvement system where part of the improvement process is that you find the bottleneck where work piles up. Most of the time, you do not need to hire more people. Move the people you have to the bottleneck instead. I've seen large projects that could have been done with 20 people, and instead they were scaled up to more than 200 people. They just kept hiring people, believing things would get done faster, and instead, work just kept piling up faster at the bottleneck. Lean software development introduced the idea of cost of delay in 2003. Now, this is an idea that still lives, in SAFe at least. However, the Lean software development version is a bit more comprehensive. For starters, Lean software development actually teaches how to create profit and loss statements that provide economic models that can be used when making decisions about a project. Lean software development also does something that might be even more important. It encourages making simple economic models when possible. This one is from a project where everyone worked in an open office environment with a lot of noise pollution. Management wanted everyone to suggest ways of reducing the noise, but every suggestion was shot down because management considered it too expensive. So I made an economic model that weighs the savings of reduced office area due to the open office policy against the loss of productivity due to noise pollution. And I could do that because there is a lot of research on both open offices and noise pollution. So the effects of either one of them is actually known. I just had to put it together. As it turned out, the noise pollution cost was enormous, much greater than the savings due to having an open office. Now, if you're interested in business agile, you've probably heard of John Boyd's Uda Loop. I came into contact with the Uda Loop while researching military and business strategy frameworks. Uda is part of a military strategic framework, Maneuver Warfare, originally created by US Air Force Colonel John Boyd. Uda is a small part of a large strategy framework. We will have a look at the framework, but first, let's look at a few definitions of what the Uda Loop is. Here are some definitions of Uda, pulled from various articles I found on the net. The interesting thing about them is that they are all quite different, and they are also wrong, all of them. Uda is not a four-stage process. It's not even a process. Uda is not an approach to decision-making. Uda itself does not tell you how to make decisions. The purpose is not learning. Learning is a part of it, but it's not the purpose. And it's not a mindset. So it's definitely not the mindset of Scrum. Okay, so what is it then? Why are people so confused about what it is? Uda is a decision-making model. It shows us how we make decisions, bad decisions as well as good decisions. The Uda model has four main parts: observe, orient, decide, and act. But the really important stuff is actually the feedback loops. The loop is not a sequence. When we make decisions, we observe, then we have a second look, we think about the decision we have to make, observe a bit more, think again, decide on a course of action, hesitate and go back to observing, decide again, and finally act. Then we observe the result of our actions. The loop itself just gives us insight into how decisions are made, both good and bad ones. Now the problem is that Uda is part of a framework. When we pull Uda from the framework, we lose context, and without the context it becomes almost impossible to understand how to use Uda. For example, you can use Uda to figure out how to improve your own decision making and make an opponent's decisions worse, but to do that you also need to understand the strategic principles. You can use Uda to improve how a team interacts, but you need to understand strategy in terms of isolation and interaction. You can use Uda to make decisions about how to build a walking skeleton and how teams should proceed from there, but you need to understand pivot points and how to enable independent command working towards a common goal through intuition developed through intense training. There's that extreme training again, right? And you need to understand mission command. And mission command requires you to understand the idea of a moral contract between a team and the organization it belongs to. Uda is extremely useful in context. Without the context, it becomes misunderstood with reduced usefulness at best, and it gets dangerous at worst. Now that was a brief tour of some of the lost treasures of Agile. I do hope some of this has been interesting enough for you to go out and look for treasure yourself. Thank you very much for listening.